Today we start our unit on circles and we'll begin by discussing the properties of tangents. First, a few definitions on circles. Let's look at this diagram here. A definition of a circle is a set of all points in a plane that are equidistant from a given point called the center. And the center is the point from which all points of a circle are equidistant. The radius is a segment whose endpoints are at the center and any point on the circle. A chord is a segment whose endpoints are on a circle, and a diameter is a chord that contains the center of the circle. A secant is a line that intersects a circle in 2 points. Notice the difference between a secant and a chord. As a chord is a line segment, whereas a secant is a line. The tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. That point is referred to the point of tangency. Let's look at this example here and decide if we have a radius, a chord, a diameter, a secant, or a tangent. Let's look at the line segment from A to C. Since C is the center of the circle and A is on the circle, we have a radius. Our segment AB goes through the center, ending on both sides of the circle, making that our diameter. Ray DE intersects our circle at 1 point on the outside. That makes it our tangent. Our line AE intersects the circle at 2 separate points and is a line, therefore it is our secant. Let's look at our theorem. A line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. That's a whole lot of words to say that these two lines, the tangent and the radius, come together to form a right angle. So let's look at this example here. PT is our radius of the circle, and we want to know if ST is tangent. Well, it would be tangent if it forms a 90-degree angle. And if we have a 90-degree angle, we can make a right triangle. And if we remember Pythagorean's theorem about right triangles, we have a squared plus b squared equals c squared. So if PT is 12, and ST is 35, and SP is 37, I can put them into my equation and see that indeed it is a right triangle because 1,369 is equal to 1,369. So yes, it is tangent to the circle. When we discuss tangents, we talk about common tangents between two circles. That is one tangent line that intersects two different circles at a single point on each circle. If my line goes in between my circles like this one does, it's called an internal tangent. And if it connects on the outside of the circles like this one does, it's referred to as an external tangent. So let's take a look at these diagrams and see how many tangents we have in common between them. So this first one, my two circles intersect at 1 point. So I can draw a tangent on the outside, on each side, plus I can draw a tangent down the middle here that's going to touch at only 1 point between those two circles. That means I can have 3 common tangents for this diagram. My next one, my two circles are inside of each other, touching at only 1 point. So now I can only draw 1 common tangent between the two circles. If my circles overlap, I can draw a common tangent on the outside, on both sides, but I can't draw one through the middle. It would intersect at 2 points this time. So now I only have 2 common tangents. Our next theorem states that our tangent segments from a common external point are congruent. That means that the distance from S to R and S to T are equal to each other. So if I have this diagram where RS is tangent to circle C at S, and RT is tangent to circle T at T, and I want to find the value of x. I can do that by setting my two equal to each other, saying that 3x plus 4 equals 28, and therefore x equals 8. That concludes our video notes for this evening's lesson. We will continue with the examples in class tomorrow. We will see you then. Have a good evening.